Okay, I think we're ready to get going. Thank you everyone for joining today. Just make sure you're in the right place. This is a Tableau Think Data Thursday. Today's topic is going to be about LOD calculations, and thanks to Josh Milligan, one of our presenters, the title is LOD of the Rings. So that's a great title. A reminder that this session will be recorded, and I'm going to actually start doing that right now. There we go. So this session will be recorded and available online to watch it at your leisure whenever you like. So if we go a little bit fast, no worries, just come back and watch the session again in the area that you're interested in doing this. First off, a little bit of introductions. My name is Patrick Vanderhyde. I work in the community and kind of help out with the different questions and issues in the community, but also oversee the platform. On our panel, we have Tracy Fitzgerald, who's our marketing strategist for the community, kind of as the overall head of everything that happens in here. So she's joining us today. And I don't see Diego in here yet, but Diego will be joining us here shortly. He's also a member of our community team. And then okay, so now, as I was saying, today's presenters are, let me go ahead and go to this. Today's presenters are Craig Bloodworth, Joshua Milligan, and Bora Beran. And Craig Bloodworth, so we have a nice little piece here. I'm going to go ahead and read off the screen for everybody. Craig developed his Tableau publishing skills through the analysis of public data sets, downloading Excel reports and poorly structured CSV files by the bucket load. Through working with the Guardian's data blog, he perfected the art of creating clean, intuitive dashboards designed to be easily understood by people who had no previous experience of BI, while also telling an interesting data discovery story. Currently, he's pursuing a goal of turning as many people onto Tableau as possible, and he does this through his work at the Information Lab and development of such tools as the Google Chrome extension for Tableau Server, and he also has the online Tableau mapping repository. So if anyone hasn't used that, I definitely recommend checking it out. It's a great help for many of us here on the analytics support team too. Joshua Milligan is also a Zen master. He's a Tableau trainer, very busy and helpful in the Tableau community. And he's appeared, let's see, his visits appeared many times on the Tableau Public Visit of the Day and the Tableau website. And he has a blog, vizpainter.com, and is the author of a brand new book, Learning Tableau. Highly recommend checking that out. It's on Amazon.com. Anyone getting going with Tableau, it's a great book, so check that out. And then last but not least, we have Bora Beran. Bora Beran is a Tableau employee here. He's our program manager for the calculations and statistics features. And he also has a blog on WordPress at boraberan.wordpress.com. And the blog covers such things as LOD Calyx. He has some great information there. Also, anyone interested in R, Bora's our go-to resource for any questions about R's and statistics. Okay. With that getting going, the format for today's session will be to utilize the panel that we have here to go ahead and go through the level of detail calculations. And we're going to start off with a few questions to kind of get going. And I'll go ahead and direct those questions to the panel. And then once we get through a few of the questions, then we're going to open up to a Q&A session to the audience. We have a very large audience today. So please send your questions on the chat panel. And if you have the option, there should be a drop down to say all attendees. Or all participants, please send a question to all participants. That way we can kind of keep everyone on the same track in terms of what questions have come in. If you do have the Q&A panel available, please don't use that because we just like to keep all the questions in one place, and it's a little easier for our panelists to follow along. Okay, with that, I'm going to unmute the rest of our panelists. There we go. And I'm going to start the session off. And I think the most important place to start is a question of what is level of detail and what are these level of detail calculations. And to get going, I'm going to ask that question to Bora, and I'm going to switch him over to be the presenter.
Okay, can you hear me now?
Yep, there we go. Thank you.
Great. Thanks everyone. Pleasure to be here. Well, let's start talking about what level of detail means in Tableau. When I talk to a lot of people regarding level of detail, people automatically assume what you put on the detail shelf determines what level of detail is. But let's start with a small example. Let's say I add sales into my biz. On the label shelf, this gives me one value because I don't have any level of detail determined in my view, which means we will get one value for the entire data set. Table is the level of detail. As I add more dimensions, I will get the value per each member of those dimensions. For example, now I see sum of sales per category, and as I keep adding more, there's going to be more granular data, finer level of detail. Or I can add a dimension like order ID or customer ID, which has a lot more members, and that will significantly increase the number of marks I have in my biz. It is probably a lot easier to summarize it this way by looking at which shelves contribute to level of details and detail and which don't. So the shelves that are and the cards marked in red are the shelves and cards that contribute to level of detail. Any dimension that you drag into these areas in your sheet will, in combination with the other dimensions in the biz, determine the level of detail. On the other hand, the ones that you see here, the tooltip card and pages and filters shelf, they do not change the level of detail. They change the viz context in different ways by filtering out the values, etc., but they won't affect the number of granularity of the results you're getting. Okay, so let's assume we have this viz. This is the same exact data, I just converted into a bar chart. Now you can see I see one bar for each of the subcategories. Prior to LOD expressions, there were ways you could have mixed levels of LOD in the same visualization. One example of this would be totals. Click on it. Now you can see I have the total for all of the values across categories. The other one would be something like a reference line. I can drag a reference line. Now you can see I have a reference line per pane. So I have two levels of detail within the same visualization. My bars are at the subcategory level, but I also have the average that shows at the category level. So while this was possible using a number of methods like table calculations, totals, sets in some scenarios, there were a lot of issues with using those methods because some of them are computed locally, so they're not as flexible as composable as we would like them to be in the calculations. So they impose a lot of limitations on what users can do. In Nino, what we wanted to do was to give a lot more flexibility to people to write these calculations, define at what level of detail they want a particular calculation to run on, and be able to mix in different parts of their analysis flow. And then came the idea of a level of detail expressions. What you're seeing in Nino is our first iteration. By just exposing it to calculation language in a very limited way, I'm hoping in the long run we'll have a lot easier to use experiences built around it and a lot more functionality. Okay, I hope that explains what level of detail is.
Yep.
As an intro.
No, that's great. Thank you. Thank you so much, Bora. Next up, I was going to have a question of, first off, to Joshua and Craig. Let me go ahead and unmute both of you guys. Do you have anything to add to what Bora just said?
I don't have anything to add. That covered it pretty well.
Okay. So the next question we had is what are LOD calcs and going into those, and I was going to direct that question at Craig. So I'm switching over presenter privileges to Craig.
All right, perfect. So yeah, thanks. So I wanted to start off with basically just a quick reference to this white paper by Alan Eldridge and Tara Walker. It covers sort of in great detail all the different types of LOD calcs and an overview of sort of what's going on. And in order to kind of explain the calculations, I've sort of picked up a couple of images from that white paper. So it's definitely good to have a read of this if you want to know more. The first calculation, and there are three, is the include level of detail calc. And this is kind of a great way to sort of show what's sort of going on in the background and how to think about how Tableau is disaggregating data from the very top when we don't have any dimensions in play, and then going through as we step through different levels of detail within the viz, and each of these charts shows the viz level of detail. So what we're sort of used to up to now, putting into play in Tableau. But then what the level of detail calc allows you to do, so pulling down, in this case, one step further down in granularity, and allowing you to aggregate at that level and then pull it back up to the viz level of detail. Then you could go further down and have these level of detail calcs push further down if you want to, or you can change the viz level of detail to push it past in terms of the include, and allow it to push past what you've defined. So essentially include is about that. It's about taking the viz level of detail at one level and allowing you to calculate something at a lower level, and then pull it back up and aggregate it. So a great example I found for that is thinking about basket value. Okay, so in terms of Superstore sales, we've got an order ID, and in order to figure out what the total value of every order was, we can use the include level of detail calc to say, well, at the level of order ID, calculate the sum of sales. Okay, so we'll quickly do that over here. So just call this, let's say, basket value. Let me see if I can zoom this in. So to get started, you could remember to do the curly brackets. So every level of detail calc start and stops with the curly brackets. If you like typing less, like I do, just go straight into one of the LOD functions. So in this case, we're going to do include, tab it, and Tableau will add in the brackets for you to remind you to put those in. So we're going to say, well, at the level of order ID, we're going to do that sum of sales. So we specify which dimensional level we want to go to, which level of detail we're pushing this calc to. Stick in a colon to separate off to say, right, that's our definition of the level. And then specify what the aggregation is, in this case, sum of sales. And finishing it off with that, closing the brackets off. Okay? So I'm going to say okay to that one. And we'll see what the sort of difference is here. So what we would have to do up until now, up until level of detail came in, was if we wanted to say work out what the average basket value was across all states in the US, we'd have to start off by getting the sum of sales at each state. But then we need to calculate the order ID. So we'd have to then bring out order ID into our viz level of detail to get every single order value, total order value, sum of sales for every single order, which creates this weird sort of stack bar, which really doesn't tell us much. And then we try and work around it. So we think, well, we do a table calc to figure out what the average was across all these orders, and then try and find a way to sort of hide all these marks in order to get us a nice, neat and tidy bar chart. The difference with that LOD calc that we just did was I can take basket value here, drag this up, replace the sum of sales, and then change it to just say average. So there I have my average basket value. And one of the great things about the LOD calc is you can regard the calculation itself as being returning a row-level result. So whereas, with table counts, we're always playing with, it's got to be aggregated, we end up trying to go around loops to get everything to be aggregated so that the calculation is valid. With LOD calcs, the result returned is just at a row level. So we can switch, we can say average, min, max on the fly if we want to. Or within the basket value, we can wrap the LOD around with, say, a standard average function, and then lock it in to, say, average basket value rather than just sort of have that flexibility. So that's the include one. And we can see, I've sort of put them side by side here to show what's going on. We aggregate it down to the viz level to state, and then we use the include to push us further down into that order ID level, and then aggregate back up to give us the average order value for each state. The next level of detail calc we can use is the opposite to that, an exclude. So where the viz level of detail is at a certain level, we can tell the level of detail calc to go back up and come back down. And this can kind of be useful for comparing, let's say, we'll go back to our state level, comparing that against a higher or lower dimension. So, for instance, if we've got state and city, yeah.
Right, just a second. There's a question that Bora and Bethany Lyons had. They're together in a room, so I was just going to unmute them for a second.
Sure, go.
Yep, go ahead, Bora and Bethany.
Yeah, hey Craig, I just wanted to ask if you could show people what's the granularity of the underlying data, just to show how that last example you did with the order ID, how the reason that we have to use a level of detail expression is because the granularity of the data is not at the order level, but it's rather at the item level. Mm-hmm. So if you just go over to the underlying data, and then just kind of scroll over to products, or just click on order ID. If you click on order ID to sort them.
Okay, sure.
The second tab.
Yeah. So there we've got multiple records for each order ID, right?
Yeah, exactly. So just really important point for everyone on the call here is that because there's multiple items on every order, if we were to just take the average sales value, that would tell us the average item value. And so the reason that we need to use a level of detail expression is because we want to do a two-pass aggregation on a level of detail that's not the raw underlying granularity of the data. But if this data had been where you have one row per order, then we could just take the average sales and everything would be fine. So just keep in mind, when you're doing a level of detail expressions, you really need to understand the granularity of your data. That's probably the most important thing.
Okay, cool, thanks. So, yeah, let's go back to the exclude and look at an example of where you might use this one. And I think one of the best ways to think about it is, I have a sum of sales value for each city and state. And what I want to do is calculate the difference between the average sales value for the state and the city to kind of see how far off the sort of state average each city is. And, you kind of do this, right, with doing an average line and sort of try and look and figure out where it is. Or, again, previously we might have done this with a table calc. Let's go and do that with an exclude level of detail. So I'm going to call this average state sales. Again, let me zoom this in. So this time I'm going to go up in my level of detail. And right now I'm at the level of city, and I want to get the average value at the level of state. So I'm going to tell it to exclude city. and return the sum of sales. I'm going to wrap this one around in an average function as well, because I've sort of set it in the name there, so I want to just lock it to be average. Okay, so I have my average state sales. I can drag that out, and we can see we get one value, well, effectively one aggregated value for all of the cities across the state, where this represents the average value for that state. And then you could go further again and, do the actual calculation. So you could say, well, take the sum of sales and minus the average state sales to see just how far off that is. Okay? So that's where exclude allows you to go back up in the level of detail. Then the third one you can do is a fixed. Now, a fixed really, although it's the third type of LOD calculation, is a combination of an exclude and an include, depending on where the viz level of detail is. Okay, so effectively it's managing both those include and exclude functions for you. So that no matter what the viz level of detail is, it locks down to that one level that you specified. And kind of a great example for this one was I've recently coming to you from Boston just after the Alteryx Inspire conference, and we've been sort of tracking as people are arriving and their flight paths have been taking. And in order to figure out sort of how long they've been in the air, I needed to calculate an arrival time and a departure time. Now, the data that I have in here is basically a lat long for every point the plane is in the air, and I have a timestamp for each lat long, but I don't have a summary for each flight to say when it took off and when it arrived. So I calculate at the level of detail of the flight ID using fixed. So I say, right, fix at the level of flight ID, give me the maximum timestamp to give me my arrival time. And then for my departure time, obviously then it's the minimum timestamp. And then that value is replicated throughout all the records, and I can figure out the time difference for the flight with, let me see if I can find that. So total flying hours is then that's not the right one. Flight time hours, there we go. There's a bit of an adjustment here, but essentially a date diff function, okay, against that departure time and arrival time, without having to worry about doing the aggregates for each, because they are just returning that row level result. Okay, so hopefully that's sort of a quick world introduction into the three LOD calcs you can do. I'm going to pass the screen across.
Yeah, Craig, could you just real quickly just show the underlying detail or underlying data associated with this view as well?
Yeah, of course. So we've got we have a bunch of attendees that come through, but then let's see if I maybe sort by flight. You can kind of see some flights have 2 attendees on, but it's essentially 1 point with a latitude longitude against it for each point along that path of the line. Okay, so the departure time for the flight was 0451, which was the minimum timestamp for that flight ID.
That's very helpful. Thank you.
Okay, no problem.
So Bora and Bethany, I was going to check in with you, see if you have any examples. And then I've seen a couple of people have a question relating to the use of table calculations and LOD calcs, and I'm wondering if there's any appropriate time for using table calcs with LOD calcs.
I have a few minor things to add. One thing you probably noticed is the fact that LOD calculations act as if they're row-level calculations in a lot of cases. So you can actually do sales minus fixed sum of sales at the level of, let's say, state, and it will not complain about the fact that you're missing a disaggregate with an aggregate. That error that nobody likes. So the reason for that is, again, we do the replication at the row level, so it doesn't appear to the calculation editor as if it was an aggregate disaggregate issue. Another topic of interest could be how exclude, include, and fixed react to what you have on the filter shelf. I can go into this. Maybe Joshua may want to go into that in detail. And one last thing would be when thinking about include and exclude, even though there are cases where your include can add something that's already in the viz, hence not change the level of detail of the viz, oftentimes, since you're adding more dimensionality, it will return a finer granularity result than the viz, which means it has to be aggregated up to the viz LOD. That's why we have the second pass aggregation that's happening on top to bring it back up to the viz LOD. In the exclude case, since it's coarser, you're removing dimensionality, then it will be automatically replicated because now you have fewer points than there are in the viz. We have to replicate to match the same number. The interesting thing to think about is you can actually nest these calculations within one another. So you can have an LOD calculation nested within another LOD calculation, and the same rules will apply in terms of replication and aggregation when the LODs or the different nested calculations are different from one another. Maybe once we go through all the topics, we can give an example of how that behaves and different things you could do with nesting. And one interesting case to talk about would be if you have a calculation that has a disjoint LOD from the viz LOD. For example, your calculation is at the state level, but your viz is at the county level. So there's no explicit state-county relationship, and how Tableau will treat it differently from having named state-county and county and they have an explicit overlap. But probably it's better to go through a few more examples before we get into the nitty-gritty details. So Bethany says she has an example.
I mean, I've got an example that might be interesting to show where because sometimes exclude, particularly, can do a lot of the same things as table calcs, but I've got an example where it does something that is not possible to do with table calcs.
Bethany, I'll go ahead. I'll go ahead and set you as a presenter. Is that okay?
Yeah.
Cool.
All right.
And I see a question about nested. I can do that after Bethany's done.
Okay, cool. Okay, so this is a data set that has some sort of medical information about the ages and diseases of various patients, the cost, and the number of patients as well. So one thing that you might be interested to look at is by different ages, by different age ranges. I'll just set the width here. What is the cost to patient ratio? So it's just a simple calc that takes the number of patients the cost and divides it by the number of patients. So then we can look at how that's broken up by different age ranges. And then we might also want to see the breakdown by disease as well. Something like this. So now the next thing you might want to look at is what's the average cost to patient ratio by disease? So you might bring in an average line here to see what that looks like per disease. But now what this is actually doing behind the scenes, if you go and edit the reference line, is it's taking an average of that ratio. And so it's basically like a weighted average because it's taking an average of the bars. But you might actually want to see the average of the raw underlying data. So not have it weighted by the age, but just be like ignoring the age, show me the cost to patient ratio by disease. And so that's something that an exclude calc would let you do, because you have the age in your viz, but you're not using it in the calculation. So then you would make just a simple exclude calc where we exclude the age from taking that ratio. And so now this is the ratio by disease. Oh, there we go. And so now, if we just add that to the viz, add it as a reference line, the ratio by disease, now you'll see that that actually gives you a different result because it's not considering the age in the view. So this is something that we never could have done before with only table calcs, because table calcs always would aggregate on top of the data in your view, and they could never ignore something that isn't in your view. Just an interesting thing here as well, you'll see now that the ratio by disease is lower for asthma, and it's higher for every other disease. And that's just simply, because there's more, the patients who have asthma tend to be a lot younger, and younger patients are generally cheaper to treat. So just kind of an interesting example to show that difference between, what you couldn't have previously done with table calcs.
Okay, Bethany and Bora, there was also a question in terms of using LOD calcs with table calcs. Is there ever an appropriate time to mix in, essentially wrap and aggregate around an LOD calc?
Well, LOD calcs are just data source calculations, so you can mix it with anything you want. You can bin them, you can put reference lines on them, you can write table calcs on them. We can talk about when to use table calcs versus LOD calcs when there are advantages, but they pretty much do what the other one does. If you're doing with table calc is doing an LOD calc technically. We have calculations like rank, etc., that are more like actual window calculations that you wouldn't be able to do with an LOD calculation. But there's a lot of overlap with things like if you're doing a total or a window sum that is not a moving average type of window. There's heavy overlap in terms of functionality, and they can choose, depending on your scenario, which one is more efficient in terms of performance, what your needs are with the results of the calculation. If you want to use the results as partitioning for another table calculation, you probably want to write that as an LOD calc because you can't use table calcs as partitioning fields for other table calcs. So it is a matter of scenario. Maybe when we go through more examples, we can get into details of that.
Okay.
Yeah, I've got another example of like when you could use a table calc on top of an LOD calc. So let's say you wanted to do a cohort analysis where you look at what's the first date of purchase of a particular customer, and then you want to be able to see across years what percent of customers come from each cohort. So here you could say fix to, I think this is one of the calcs that Craig had shown, where you fix to the customer level the minimum order date. So this is now your cohort. And then we can drag this cohort out to color the bars. And so now that shows us, for example, in 2014, that the majority of our customers were actually from the 2011 cohort, and that we acquired very few customers in the 2014 cohort. But you might actually want to see as a percent of total, like what percent of my total customer base in 2014 came from each cohort. So then you could add a table calc on top of that, percent of total here, and then we can just compute that using the cohort. And now we see that 74% of the customers that purchased in 2014 came from the 2011 cohort. So that's just to give you an idea of how you can use a table calc and compute it along an LOD expression.
Okay, so I'm taking the ball from Bethany, if I can. So we can talk about.
Don't let her talk anymore.
It won't let me drag it.
I think, Patrick, you have to I'll stop sharing my screen.
So there are two questions. One is about how to write nested, and the other one is how you can have multiple dimensions listed in the dimensionality expression.
Okay, Bora, do you want to go ahead and share your screen? I have a...
Okay. So this is an example of a nested calculation that happens to also show how we would have multiple dimensionalities in the dimensionality expression. And what I'm referring to is, as the dimensionality expression, is what follows the keyword. In this case, the first one has state and customer, and the second one is fixed state, comma, customer. You can put as many dimensions as you want, still limited by commas. One thing we require at this point is they actually be the field name. So if you have, let's say, a date field and you wanted to get the year out of it, you cannot, in NINO at least, you cannot say year date to get just the year value out of it. What you need to do is create a calculated field that contains year date, then refer to the name of the field in your dimensionality expression. So what's happening here is you can see I have a nested calculation. The inner calculation is include customer sum of sales in the first case. Then we wrap it in an aggregate, then it just goes into the next one like any other aggregate. So it's no different from sales in the inner calc, that we have a whole LOD expression inside average aggregation. As I said, since they act like row-level calculations, I can put it inside an aggregate. The other detail here is I just wanted to show an example where you can see how you can write the same calculation in different ways, because there is also some inheritance rules that apply to nested calculations. The inner calculation will inherit the context from the outer calculation. So since the outer calculation says fixed state, the inner says include customer, it will include state and customer within the context of sum of sales. I could have written the same thing by explicitly naming out state and customer in the inner calculation. It will give me the same results in this case. I hope that explains the question about the syntax for nested and how you can use multiple dimensions. That's all I have for that question.
Great. Okay.
Thank you.
Yeah, thank you, Bora. I'm going to go ahead and switch over to Joshua. Joshua, you had a few examples as well to show us. I'm going to change you to presenter. And I'm going to unmute. Oh, yeah, you are right there.
All right, great. Yeah, so one of the questions that came up was table calculations versus LODs, and when should I use them versus not? So several things were mentioned already. So ranking is something that can be done, maybe nesting a bunch of LOD calcs together. I've seen that done, but you have to do a new nesting for each rank level that you want. So that's a place where table calculations is going to be preferred. Some other places might be the windowing functions where the window is smaller than the partition, so a running average or some sort of a running table calculation. But then there are times when table calculations are very difficult or sometimes even not possible. So one example of that might be if I have a data set that looks something like this. So I've got a customer type and customers and a date. And what this is this is a banking data set that shows me a balance, except that in the data itself, it's actually a running balance. So I can see how much was in the account at a given date. And whatever that last date is, that's the actual amount in the account today. So Frodo has $755, Gandalf has $900. And now the question is how can I get the current the current balance in the account. Well, before version 9 and level of detail, I would have probably been using some sort of a table calculation. So I would have maybe tried last, and we'll change that to discrete just so we can see it. And so what I'm looking for is the last for the date. So I would have gone to compute using date. And now I'm starting to get confused because I'm seeing some data densification going on, and things are getting complex. And so now I turn to Joe Mako, and he tells me we'll put date down here and make this one an attribute. And so I get this far, and I realize, oh, okay, now I've got that 0, and that's good. That's what I want. So I'll move that over to the filters, keep only the zeros. And now I'm looking pretty good. I've got the current balance. That's what I want, and I'm happy until my boss says, put the totals on. And now I'm scrambling, and I'm looking at Jonathan Drummy's post on customizing grand totals, and then my boss says, oh no, I don't want to see it by customer. I want to see it by customer type. And so whereas I was seeing 755, 100, 200, etc., I go down to the customer type. And now I'm really confused. What's going on? So I would have had to do all kinds of tricks with the table calc, and that's when I realize I don't need a table calc. I can use a level of detail. So I come back to my data set. I look at the customer type, the customer, the date, and now I can do a level of detail calculation. So we'll create a calculated field, and we'll call this our last date per customer. And I'll do a fixed table calc at the customer level. And I want the max date. So I'll say OK. And then, as was mentioned before, the fixed table calculation does show up at a row level, which is really nice. So if I check that, that's giving me the last date for each customer, and it does indeed match the last date. So now, since I can use it as a row level calculation, I can create another calculated field that just says, is it the last date? And I can compare the date and the last date per customer, get a true false, and use it as a filter. Now I'm only seeing that last date per customer, and now I can do things like turn on totals. Well, let's actually put the balance in there. And things are working fine, and I can go down to just or up to just the customer type, and I'm getting the right results. So much easier than the table calculation, much more straightforward, and just a few steps, and everything works like I expect it to work.
Joshua, there was a question that came up from Toby about any general rules about when to think about table calcs versus LOD calcs. Is there anything that you kind of look at and go, oh, this is the perfect place for an LOD calc versus that table calc?
Mm-hmm. So I'm going to steal this list from Jonathan Drummey. He sent me a list of things to think about. So ranking is something that a level of detail can't do. So I would use table calculation. Relative lookups, I can't do that with a level of detail. But when should I use it? Anytime that I can think of things as just I need to work at it at a different level of detail. So I need the maximum date at a customer level, or I need the average sales per order. So if I find myself asking those types of questions, that's when I'm going to start to think, okay, that's when I need a a level of detail calculation, especially if that level of detail doesn't match what I'm going to be using in my view. If it matches, I'll just use a regular aggregation, but if it doesn't, that's when I'm going to start to think level of detail.
Great, thank you. So at this point, I'm going to unmute the rest of the panelists, and there we go. And we had some questions in here. I think Bethany wanted to go ahead and Bethany and Bora wanted to add on to what you just showed. Bora, should I go ahead and make you the presenter for a moment?
You can make Bethany the presenter if you like. Something.
I didn't really have anything to show, but just something to say, I guess, in terms of like my mental model of like, do you need an LOD calc or a table calc? I think like one question that will help you identify what you need is, does the order of my data matter to answer this question? Because LOD expressions, they're just aggregations, so the sum, the average, the maximum, the minimum, and you can figure out all of that stuff without ever needing to know the order of things. But once you need to know the order of things, then you need a table calc. So something like, like ranks or percentiles, or if I want to know the top N% of my customers, you have to be able to order all of your customers to figure out if they're in the top N%. So something like that would need a table calc. Again, so if you want to find the first date of purchase of a customer, that's just the minimum, so you can figure that out with an LOD calc. But if you want to find the nth day of purchase of a customer, then you need to be able to order your data to figure out if it was the first, second, third, fourth time that they made a purchase. And so in that case, you would need a table calc. So that's kind of the main difference, is this like ordinal property of the data.
That's great. Thank you. So we have some questions that have come in, and I thought we could just jump over to those unless anyone else has some things that they've prepared that they would like to add. Craig, did you have anything else? We haven't talked to you for a little bit. Do you have anything else that you wanted to add?
No, I think for me the question of which one to select, it comes down to a point. So Joshua touched on there about when you're coming to write it, are you sort of saying I need to know this aggregate value by something, or is that kind of written into the way you're thinking? And if it is, then chances are that you can just write it straight there in the calculation in the LOD calc. Whereas I sort of think that the order of the data is important. I always think is there movement in the data? Is the result I'm trying to get, does it have like a movement and the sort of order to it? In which case, then it's you can look at the running total or the index or something.
Great, thank you. So one of the questions I'm reading, it's a little bit longer here. It says, I use retail. This is from William Strauss. This says, I use retail transaction data. Can I nest all of the detail lines from a series of transactions and show totals for all items in a SKU line versus tender lines versus discount lines, while still keeping the raw data in its original format?
I think we're all going to have 5 minutes to decode that one.
I'm going to say the answer is yes, but I have no idea how right off. Anything's possible with Tableau, but might need to see it.
And then I also see a question here related to rank. You could use, it seems theoretical that you could use LOD for rank if your rank is based on total sales by item. For instance, to get a list of best-selling items, if you used fixed product sum of sales. Is this correct?
I think that it depends. If you're actually wanting to get the rank value out, you wouldn't get it from that. But if you were trying to do a filter to get the top 5 or top 10, then essentially yes.
Okay, Windows sum can be replaced by so one question was can you replace Windows sum with the exclude in the LOD? And I would not say that those things are synonymous. Those things are the same. Windows sum and but go ahead and your response for those.
I think there is the crossover between the two. There's lots of examples where you could say you can throw out one and replace it with the other, or vice versa. I guess sometimes and talking with Joe Mako yesterday, then how you think about how these things are computed, and it could have quite heavily impact sort of performance on your end result. So with LOD Calyx doing sort of subqueries directly in the database, if your database is struggling even to just get sort of the data out, then that could sort of hamper the end user results and performance. Whereas once the data's out, maybe your local machine is a lot quicker, and so a table calc would get that result much faster. And then there's probably examples where it's the other way as well.
That's great. So I'm just looking to see if there's any other questions. If any other panelists see a question that we haven't addressed.
So there's one there about rank from Kathy. She says it seems like theoretically you could use LOD for rank if your rank is based on the total sales per item, for instance. So you could get a list of the best-selling items if you use the fixed, and then fix it at a product level, sum sales. So I think my thinking about rank is if I want the absolute rank of something, so 1, 2, 3, 4, 5, and so on, that's where level of detail is going to be really difficult to get that absolute ranking. But yeah, if I want to use it just to get the relative ordering, yeah, absolutely. I could fix it at a product level, get the sum of sales, and then use that in some way to order it, and I know which one had the most, the second most, and so on. So yeah, but in order to get those exact absolute values of rank, I'm probably going to use a table calc.
Yeah, plus there are ties, etc. Rank will, depending on the algorithm, will treat it differently.
Can we just show an example of how you do that?
Well, we have 5 minutes
we
left.
have 5 minutes.
So.
Yep. There was. I should say, Bethany, maybe we want to just show your real quick your blog post about LOD expressions. That might be one other good thing to get up on the screen really fast for everybody as they go back and review this.
Yeah. Sure. Do you have the? Yeah, perfect. So yeah, if you just search LOD expressions, you'll find this post here. It goes through 15 examples of level of detail expressions. So you can download each of these workbooks, and they actually have like step-by-step instructions of, where do you start, and then how do you come up with the expression, and then how do you build the viz. So this might be a good resource if some of the abstract stuff is maybe a bit difficult to grasp, and yeah, it might be easier to start with examples and then read the white paper that kind of abstracts it a bit more.
One thing we have not mentioned is how filters interact with LOD calculations. I think either one of my blog posts or the white paper will go into detail about how fixed calculations will not be affected by filters other than the context filters. So you can do interesting tricks by putting a fixed calculation with a non-fixed calculation and have your filters filter out one of the results and not the other one. A lot of people do things like a proportional brushing almost using that method, which has some other side effects, but we don't have time to talk about it. But yeah, I have a really long detailed post about what happens behind the scenes, the inner joins we're generating, how the LOD calcs interact with totals? If you do a total on top of an LOD calc, how would it act? Because we have things like replication happening, what totals be skewed by replication, what kinds of totals will ignore the replication. All of the details you can find in here. I also have examples of disjoint LODs and how you can do interesting tricks. Like if you have, let's say, people who make purchases in multiple states, but you wanted to say, well, I want to get some of spending for the customer across the entire country, but replicated at the state level at each state they ever shopped. So then you have to compute it at one level, replicate it at a different level. There are a lot of nifty tricks you can do, and there are tons of examples in my blog post and Bethany's blog post as well.
Yeah, just to give you kind of a taste of like what Bora's talking about. One of the examples down here displays proportional brushing. So the way that Tableau works by default is if you filter on something, it will show you only the data related to that one selection. But now what you can do is build views where the filter applies to only a subset of fields in your view. So what this is showing you here is China's sales relative to total sales in Asia. So this is just using the concept that Bora was just mentioning, where you kind of can manipulate the order of filtering versus LOD expressions happening. So if that interests you, Bora's blog goes into the technical details. This will go into kind of how do you replicate this scenario.
Thank you. And Bethany, I just want to thank you again for joining as well. We didn't have you on the presenter list, but Bethany Lyons is an employee here as well as Tableau and has been a guest on the Think Data Thursday presentations before. So thank you, Bethany, for joining and helping out today. So I'm going to go ahead and switch on over and there we go, and share my screen. And this will be the end of today's Think Data Thursday. Thank you to everyone who presented. A couple of reminders. One is most everyone here on the panel are active participants in the community. If you have questions about LOD calcs that you can't find an answer for, please come to the community and ask your questions there. Lots of people are willing to help out and share. Just a second. Yep, share their wisdom with everyone else, and if you want to meet some of these people in person and learn more and have some kind of hands-on time, please come to TC 2015, where it's going to be this year in Las Vegas, and so that's a great event to go to, an opportunity to learn and use Tableau in person. And then just thinking about our next Think Data Thursday, looking ahead, our next Think Data Thursday will be on June 18th, and the host for that event will be Diego Medrano. So he's going to explain a little bit about that event, and then we'll call it a day. Thank